Okay, so if you read that section on Avogadro's law and you're having a hard time with it, I thought I would just do a quick video because I did not include it in the original Charles and Boyle's and combined gas law. We don't do a lot of this with Avogadro because mostly in our gas law labs, we have a set amount of gas. We vary its temperature, its pressure, its volume, but we don't let any of the gas escape. So we're talking about a set amount of gas. However, you could have a situation where some gas is allowed to escape or gas is added, and then you'd have more moles of it. And so you definitely could have a relationship here, and of course it's a direct relationship. If I'm able to keep the temperature and pressure constant, if I reduce the number of moles, the volume is going to go down. Now, if I tried to shove more gas into the container or pump more gas into the container, the pressure, and I didn't change the volume, the pressure would certainly go up in it. The temperature would go up. But if somehow I allow that pressure not to go up, I allow the container to expand, what's going to happen here is I'm going to be able to keep that temperature and pressure constant, and of course the volume is going to go up because the moles of gas go up. So it's a direct relationship. So if we wanted to take a quick look at this, let's say that we have a certain temperature and pressure. We have 3.5 moles of gas and it occupies 6.7 liters, so that's our V1, and that's our moles 1. And we're going to keep that temperature and pressure constant by reducing the volume, of course, and we're going to do that because we're going to allow 1.3 moles of gas to escape, and the new volume is going to go down to keep that temperature and pressure constant. And so using this formula right here, I'm going to put 6.7 liters here. The initial is 3.5 moles of gas. And we don't know what V2 is, but we do know that we're going to lose 1.3 moles of gas are allowed to escape. So 3.5 minus 1.3 is going to leave us in that container only 2.2 moles. And so when we cross multiply here, we're going to go 6.7 times 2.2 and get 14.74. Cross multiplying here, and then we're going to multiply these, and we're going to get 3.5V. I'm going to divide both sides by 3.5, and we end up with a second volume, which we knew to be the case is 4.2 liters. So we had 6.7 liters when we had it contained 3.5 moles. We allowed 1.3 moles to escape, leaving us with only 2.2 moles. So in order to have temperature and pressure constant, we would have to lower the volume. And so that's Avogadro's law. So we can then look at the combined gas law, which was in the last video, and see that normally what we look at is pressure and temperature and volume and how that changes. We don't generally change the moles of gas, but as you see, we certainly can.